Hey everyone, today is 24th July 2024 and we are going to solve the problem of the day, which is sort the jumbled numbers. So we are given a zero index integer array mapping which represent the mapping value of a shuffled decimal system. So basically, if mappings of I is j, we can say that I is to be mapped to j. The size of the mapping array is 10, we can see here, 0 to 9. So given that, if we want to find a mapping of a number, we want to replace each digit in that number by its corresponding mapped value. So if let's say we want to find mapping of 991, we'll check what is at the ninth position in our mapping, which is 6. So we'll put 6 here. Then again for 9, we'll put 6. For 1, we'll check the one position, which is 9. So we'll put 9 here. So we got the mapped value for that number. Now what we want to do is, we are also given an integer array nums, this one, and we want to return the nums sorted in non-decreasing order based on the maps value of its element. So here are the few notes. One is elements with the same mapped value should appear in the same relative order in the input. And elements of nums should only be sorted based on their mapped values and not to be replaced by them. So we don't have to replace these values. We just need to sort them by their corresponding mapping. How we can do that? So let's start with the algorithm. What we can do here is we can we need to find the mapping of each element, right? So we'll go over nums, find the mapping for it, and we'll create a pairs for them like we did for the last problem. So we'll create the pairs for it. So what will the pairs look like? So the pairs will be like this. It will 991 is mapped to 669. So I'm just assuming that right now that we can somehow get the mapped value. Then we'll write the algorithm how to get the mapped value, but first let's assume that. Then for 338 it will be 7. Then for 38 it will also be 7. And now just like the yesterday's problem, we can apply a sorting algorithm here based on the second value, and the sorted pair, let's say, would look something like this. So we'll have 338. We'll write the lambda function for it. So I'll make sure that only if the uh, mapped value is strictly lesser than another map value, then only it comes in the front. So 38 will not come in front of 338 because I'll write the lambda function like that. But then it will be 38 map to 7, then it will be 991 map to 669. Okay, so this will be a sorted pairs, and then we can just iterate over the sorted pairs, and we can return we extract the first values and return it in the answer. So our answer will simply become like this, 38 and 990. Okay, so I'll start coding with this, then we'll come to how we'll form the function for finding the mapped value. Okay, so we need to iterate over the nums array first. So for int num, in nums, we want to store the pair somewhere, so we'll make the vector of pair into int pairs. Now we'll just pairs dot push back the num and the map value. So the map value is equal to value mapper, let's say a function which takes the num and the mapping and returns us the mapped value. So we'll push it to the pairs. So let's say it works for now. Then what we want to do is we have the pairs right now, then we want to sort them. Sorry. So let's apply the sorting. Sort pairs dot begin to pairs dot end, and the lambda function is written like this, just like we did yesterday. Okay, like this. And the arguments for it will be A and B, which are, since we are iterating over the array of pairs, each iterator will itself be a pair. So we'll return if a dot second values are map values, so a dot second strictly less than b dot second, then only it will come in front. So here's the sorted, then we'll have the vector in answer which we want to return, and how we'll form that is we'll iterate over the sorted pairs and push the pair dot first to it. So for auto iterator pairs, we simply push back iterator dot first value and we return the answer. Okay, so this is the main algorithm, but we need to write the value mapper for it. So let's write that. So it will return an integer value mapper. It takes a integer num and a vector int mapping. So the easier approach to go about it is convert this num to string. So once we have a string 991, we can simply check for its corresponding value in the mapping, and then we can form a string again, this 669, and then we can convert it to integer again. So that is the easier approach to understand. Another one is by using math, and we find the modulo by 10 each time and add it to our answer. But it's basically a little bit more complex to understand. So I'll go with the string method. So the string snum is equal to our toString method, toString on num. So we have the num as a string. Now we want to go over this num. So for int I is equal to 0, I less than snum dot size I plus plus. Okay, and we want a builder also, which is empty for now, and we'll do builder plus is equal to and its corresponding mapping. So to that also we'll have to do toString and mapping of. So we need to find the index of this, right? So we'll get the from the string num, we'll get the ith character, and we'll have to subtract basically 0 from it to get the index. So that's where we'll have the mapping. We'll put it in the builder, and we can simply return the string to integer of builder. And yeah, that looks pretty much it. Let's see if it works. Okay, what's the issue? Pushback. Yeah, we cannot put pairs like this. We have to make a so it's working. Let's submit this and check the time complexity. So it beats 34%. It's quite efficient. So actually I submitted one with by using the integer method. So let me check that also. That was actually a bit faster. Yeah, it was quite a bit faster, this one. So basically let's do the time complexity analysis for this code. So what we're doing here is we are going over each num. So this will take n time. It is the length of nums. Then for each value we're finding the value, we're calling the value mapper. So it takes the time which is equal to the length of the num, length of num. Yeah, n into length of num. Pairs dot pushback takes constant time, so we don't count that. Sorting takes pairs is basically n length only. So n log n time. So this is taking our n times log n time. This, and this is also n time. So at the end, what we have here is n plus n into length of num, then n log n plus n. So whichever is the greater of these two, n of length of num and n of log n, will be our asymptotic time complexity. So if we check the constraints of the problem, here the length of num can only be 9 because 10 raised to power 9 is the constraint on nums of I. So which is analogous to, we can say, the log of 30,000 here. So n log n is a pretty good asymptotic time complexity, we can say. So n log n is a time complexity here. Uh, One thing which is why my two solutions differ. One is the string method and second is the integer method, is because this value mapper is not actually taking length of num time here. It is taking three times the length of num, because it first has to convert the num to string, which takes the length of num times. Then it has to iterate over that and again map it, and then it has to again convert the string to integer. So it takes three times that. So it is actually 3 into. But since we ignore the constant, the asymptotic time complexity remains the same, but there is a noticeable difference in the two submissions. All right. So I can show the code for this also. In this, just we how we find map value is a bit different. We start with the builder is 0 and I is a position. We take the least significant digit out of our num. We find a mapping for that digit, and we basically multiply this receiving digit by 10 raised to the power I and add it to our answer. That's how we build our answer and we return that. So this is a bit efficient. Yeah. So that was it. Thank you.